Welcome to the next lecture. Uh, am I audible, guys? I hope I'm audible. If you have any problem, just do let me know in the comment section. Okay. So in the last session, we have been discussed about problems which are related to rectifiers. Let us continue from there. First, I have given one question in the last lecture. I hope you might have remember. Take that question one more time. Try to bring the answer. Okay, I just wanted to know the answer for this question. They have given one SCR and its peak voltage, forward peak voltage. What they have given? Its forward peak voltage is 1800 volt. The highest average current is given as 100 ampere. There are two type of converter. Basically, we know in single phase and even in three phase also we can design two type of converters. With the help of midpoint also we can design the converter, and we can also design the converter with the help of bridge, but both will give you the output voltage will become same. There will be no changes, but you all know what could be the difference between this midpoint converter and the bridge converter. We might have seen the major difference between the midpoint converter and the bridge converter at some point. This is the difference between these two converter, like that. There will be some important points. If you guys do remember those 2 points, it will be very easy to bring the answer for this question. Any of you might got the answer for this? Any idea? Answer means I have tried in this way, like I got this answer. Like that. Whatever you got, you can just drop it in the comment section. And I will try to do my best from my side, okay? Okay. See, let's see. Let me drop the question. First, keep smile in your face and be happy. Be active while solving the problems. Be energetic. Be conscious. Be fast, such that accuracy will come. And time management. Within the given time, you should be able to solve all type of questions. That's very important. Okay. Okay, sir. Chalo. See, basically, what they have given in this question is, sir, there is one SCR and its peak forward voltage is 1800. Okay, let us collect the data outside. Its peak forward voltage is 1800. That's fine. We will take that. Peak forward voltage of the SCR is 1800 voltage. Fine, sir. Next, they told the Thyristor average current. That is the one more data that they have given. Current value is 100 ampere. That is given. Fine, sir. Next, is there anything else to discuss after that? Yes, they have given one more point that is called safety factor. This value is basically called 2.5. Just they told. I asked you all to see what is safety factor and what is safe operating area in Thyristor. In free time, you can read it. Okay, fine, sir. Next, they are discussing about midpoint converter and bridge converter. You might have seen midpoint converter means with the help of transformers, we are trying to design the full converter, single phase full converter. Okay, sir. So let us go ahead with the midpoint converter. What is the difference when you people are going along with this? Suppose if I am designing a circuit, a single phase full wave rectifier with the help of a midpoint converter, then the peak inverse voltage, the maximum negative voltage that can be peak inverse voltage means you all know, right? That is negative peak voltage. Peak inverse voltage that will be dropped across the diode in case of full bridge midpoint, sorry, in case of midpoint full wave rectifier is 2 times of maximum voltage. Yes or no? That is the difference. But if you take full wave, that is full bridge rectifier, if you are designing full bridge rectifier, then the peak inverse voltage of it will become only Vmax. So that is the first difference between these two. Okay, sir, just by keeping these two, what can we do? Basically, what is the question? The power handled by these two converters separately we have to find. First, we should find the power handled by the midpoint converter. Then we have to find out the power handled by the bridge converter. It's very good question, right? Yes, sir. Just by keeping this data, how can we do that? Just think about it. Now, I just wanted to know, first I'm just asking you, what can be the expected maximum average output voltage? That is what we have to identify. Then it is very easy to identify the power. Yes or no? What they're asking, power handling in the sense, what is the maximum output power that can be delivered by these converters? Maximum expected power, handling power. Handling power means what can be the maximum power that can be converted. It depends on the amount of voltage, output voltage. We can say V naught average into I naught average. Yes, sir. It depends on these two values. It is very easy to say. Fine, sir. Now they have given one more thing. What they have given, the value of the thyristor average current we know what it's given. Given it is 100 ampere. Okay, sir. So with the help of thyristor average current, is there any possibility to identify the power? This is on-state average current of the thyristors. Okay, sir. We know on-state average current of the thyristor. So what can we do with this? I'm just asking you two people. Just think, do something and try to bring out the answer. Okay, sir. I just wanted to know the value of V naught average and the I naught average. If you figure out these two, it is very easy. Fine. Now I'm asking you the next question. The next question is V naught average formula. In both cases, in midpoint converter and full bridge converter, in both cases, what is the V naught average formula? It is same for both people. Yes or no? Yes, we can say the value of V naught average is 2 times of maximum voltage 2 Vm by pi into cos alpha. This formula is common for both midpoint converter and full bridge converter. But here it is very important to identify the value of maximum voltage. How do I figure out this maximum voltage? That will be our next target. How do I figure out this? Just keep your attention with this and try to bring the answer. That's all. Then easily we will be getting the answer from here. They have given one key point. One is safety factor, another one is maximum peak forward voltage that can be dropped across the thyristor. That is what they have given, right? அதாவது தைரிஸ்ட்ரால வந்து மேக்ஸிமம் இவ்வளோ வோல்டேஜ் வந்து பிளாக் பண்ண முடியும் அப்படின்னு சொல்லிட்டு ஒரு இது வந்து கொடுத்துருக்காங்க இல்லையா? ஸோ பேசிக்கலி தி மேக்ஸிமம் எபிலிட்டி ஆஃப் தி தைரிஸ்டால வந்து மேக்ஸிமம் எவ்வளோ வோல்டேஜ் வந்து பிளாக் பண்ண முடியும் அப்படின்னு பார்த்தீங்கன்னா இப்போ ஜஸ்ட் நோ விசா இன் கேஸ் ஆஃப் மிட் பாயிண்ட் கன்வெர்ட்டர் தே ஹேவ் கிவன் பீக் ஃபார்வர்ட் வோல்டேஜ். ஃபார்வர்டில் அது மேக்ஸிமம் பிளாக் பண்ணுற வோல்டேஜ் வந்து 1800. The overall blocking ability of the thyristor we just wanted to know, that is maximum peak inverse voltage, that is 2 times of Vn. Now we should not consider only this value. From this I just wanted to know this. அப்ப இங்க இருந்து நம்ம என்ன கண்டுபிடிக்கலாம் அப்படின்னா, it is possible to identify the value of, let me tell you, if you take this 2 times of Vmax, that is peak inverse voltage. Yes sir, that is true. And the next thing is, if you are multiplying it by safety factor, that will give you the value of maximum forward peak voltage. From this we can easily calculate the value of maximum okay, let me write like this, maximum forward peak voltage. This is the problem with you, all right? Safety factor அப்படிங்கிறது இட்ஸ் நம்பர். இது வந்து நம்ம ஈஸியாக வந்து கண்டுபிடிச்சு வச்சிருப்பாங்க. அதாவது அப்சர்வேஷனில் இப்போ இந்த தைரிஸ்டருக்கு வந்து மல்டிப்ளிகேஷன் ஃபேக்டர் வந்து 2ஆல் மல்டிபிள் பண்ணால் ஆல்ரெடி இப்போ பீக் இன்வெர்ஸ் வோல்டேஜ் வந்து ஒரு 1000 வருது அப்படின்னா அதை 2ஆல் மல்டிபிள் பண்ணால் நீங்கள் வந்து உங்களுக்கு என்ன வோல்டேஜ் வருதோ அந்த வோல்டேஜ் வரைக்கும் வந்து ஃபார்வர்டில் வந்து தைரிஸ்டரால் வந்து பிளாக் பண்ண முடியும். Like that, a common safety factor will be different for each and every thyristor. Here, in the same way, if you multiply peak inverse voltage by safety factor, that will give you the value of forward peak voltage, maximum voltage in the block. Okay, sir. Now, what it is given? From this, I can say the value of 2 times of Vm equal to forward peak voltage upon safety factor S into F. It will be equal to, what is the value of forward peak voltage? 1800. It is already clearly given, divided by what is the value of safety factor? It is 2.5. Now it is time to cancel this. If I will cancel 18 by 2.5, how many times of 2.5 will be there? It will be, I hope first we will be getting 16 times of 2.5 will give you 15. Okay, we can go 7 times, right? 7 times of 2.5 will give you 17.5. Yes or no? Yes, we are correct. So remainder will be 0.5. Again, we have to add it with the this double zero. So if you add it with the double zero, again it will become 500. Such that once again, if I will cancel it by 2.5, what will be getting? 20 times of 2.5. Yes or no? That's all. So totally we will be getting 720. See, I have figured out the value of 2 times of Vm from here. Yes, I just wanted to know the value of 2 times of Vm only, because see there, here I can directly substitute 2 Vm can be replaced by this 720. It is very easy. Yes, sir, we can substitute it here. Now, what can be the expected value of alpha, sir? Alpha is not given. They told that this is midpoint converter only. And it is clearly given that that is silicon controlled rectifier. So what can be the expected value of alpha now? What they told, they have given maximum peak forward voltage. Actually, maximum peak forward voltage of the circuit is given as 1800. Fine, sir. So what can be the expected value of alpha? We are trying to estimate the maximum power. When we will be achieving the maximum power? It could be possible when the average value of the output voltage also will become maximum. When average value of maximum voltage will become, when average output voltage will become maximum, it could be possible only when alpha equal to, only when the value of cos alpha equal to 1. Yes or no? That is the maximum value of cos alpha. We cannot change the value of voltage, but we can maximize the value of alpha. Listen, basically I not v not I want v not average maximum. So I'm just trying to achieve the maximum V naught average. This can be written as 2 Vm by pi into cosine of alpha. This is the variable factor here. We know alpha is the variable. By varying the value of alpha, we are trying to achieve the maximum voltage. And if you want to know the value of V naught average maximum, it will become maximum. This value will be maximized. Its expected maximum value will be 2 Vm by pi. It could be possible only when the value of cos alpha will achieve its maximum value. Its maximum value will be 1 only. Yes or no? So what I can keep here is, we can assume that the value of cos alpha will be maximum, because they are asking, given it is peak forward voltage. இது எல்லாமே நீங்களா தான் ஐடென்டிஃபை பண்ணணும். ஏன்னா அவங்க என்ன கொடுத்துருக்காங்கன்னா மேக்ஸிமம் ஃபார்வர்ட் வோல்டேஜ் தட் கேன் பி டிராப்ட் அக்ராஸ் தி தைரிஸ்டர் தான் கொடுத்துருக்காங்க. So with the help of that voltage, I am trying to maximize everything. What is the maximum power that can be handled by the whole circuit? அப்போ maximum power handled by the whole circuit அப்படிங்கிறப்ப I just wanted to know the maximum output average voltage. Okay, sir, that's fine. That's what we are trying to mean here. From this, now we can substitute. So what we can say, the value of output power for the midpoint converter, maximum output power we are calculating for the midpoint converter will become 2 Vm by pi, cos alpha will be 1 now, into thyristor average current. From that we have to substitute the value of I naught average. That's all. If you substitute these two, you will be getting the correct answer. Okay, sir. Now, when it is become 2 Vm by pi, just now we figure out the value of 2 Vm, that 2 equal to what? 720, right? Yes, it is 720. You can substitute that value here, divided by pi. Now tell me, what is the expected average value of the output current? Wait. Question first நம்ம என்ன பண்ண போறோம், we are let us keep our attention to midpoint converter. இப்போ இந்த midpoint converterல வந்து maximum எவ்வளவு current வந்து handle பண்ண முடியும்னு கேட்டிருக்காங்க இல்லையா. Now so what I can substitute, sir? Either I can directly substitute the value of average value of the thyristor current, or do I need to do something else? It's a beautiful question. Now think about it. What I'm going to do is, instead of considering this output current directly, I'm going to consider the value of thyristor current. Why, sir? Why? Because in the question what they are asking is, they have given the maximum forward peak voltage blocked by the thyristor. Thyristor வழியா போற forward peak voltage கொடுத்திருந்தாங்க. With the help of that, we figure out the maximum output voltage. Now, maximum power that can be handled by the circuit, in the sense, if I am estimating the maximum power, we all know the average value of the output current. We have done this many times. The output average value of the full converter is equal to 2 times of average value of the thyristor current. Yes or no? You can see our previous questions. What we done, thyristor average current equal to I naught current divided by 2. But here what I am going to do is, we have to identify the maximum power that can be flow from the source and then through the thyristor and then through the load, because the question is maximum power handled by the converters, not only the maximum output power that is delivered through the thyristor. What can be the maximum power that can be delivered? Are you getting me? So in that case, I cannot maximize the current, because if I will double this current, if I am taking the output current equal to 2 times of thyristor average current, then what will happen? The current that can be handled by the thyristor is only 100 ampere. If I will multiply it by 2, then it will become 200 ampere. This much of current cannot be flow through the converter. So I cannot say this is the current handled by the converter. So this is wrong answer. So here what I'm going to do is, I'm going to just consider thyristor current only. In place of output current, I'm directly considering average value of the thyristor current. Remember one more thing, if they are asking only what is the output power, then there will be no issues in the question. But the question is, what is the power handled, power delivered through the thyristor? Two converters, ரெண்டு converter வந்து எவ்வளவு power delivery பண்ணுன்றதுதான் question. So I have to identify the power that can be flow from the source through the thyristor and then to the load. So power that can be flow handled by the converter, in the sense, இது வழியா எவ்வளவு power போகுது அப்படிங்கிறப்ப I have to consider the average value of the thyristor current only. I cannot consider the output current. Let me repeat again. If I substitute the output current here, then the current rating will be doubled. That current cannot be handled by the thyristor. Thyristor can handle only 100 ampere. If I substitute 200 ampere, then thyristor will get damaged. So you have to observe. Some questions are little tricky, and you should apply your common sense also. So here I am going to directly substitute the value of average value of the thyristor current, and I had given the proper explanation for that. So what is the expected answer? It will be 720 into 100. It will become 72,000 upon pi. So now if you estimate the value of 72,000 upon pi, you can expect the power could be 22.918 kilowatt. That is the power that can be handled by the converters in case of midpoint. Now it is time to explore the second one. Now you know everything. Safety factor. I told you how to handle the safety factor. Just now you guys have seen that. Yes or no? Okay, sir. Yes, we have seen. With the help of that, how do I figure out this? It is very easy. You can easily find out this. Because just now I told you, if you take full converter, can you please help me now? Full converter can you try பண்ணலாம்ல, because I told. Sir, load பத்தி சொல்லல. V0க்கு RL load formula choose பண்ணீங்க. Guys, listen. Yesterday in the class also I told you 2 Vm by pi. It is the generalized formula for the full converter. Sir, when can we use this formula? For all continuous load. Sir, how can I identify whether the given load is continuous or not? In the given circuit, in the given question, if there will be no any information about the type of the load that they are connecting, then by default you can assume that the converter is producing continuous load. It means your output current will be ripple free. When there will be no any information about the output current, you can assume that the current is always continuous in the output side and it is ripple free. Remember, even some of you are asking that, sir, output la RL load மட்டும் தான் இதை நம்ம choose பண்ண முடியும் அப்படின்ட்டு. Even in RL load also, the value of inductance must be large to consider this formula, such that you will be getting continuous current. I told you, no, output current will become continuous only when the moment you are connecting a large value of inductance in the output side. Then only it could be possible. Inductor only will take the responsibility to produce the ripple free current in anywhere, any kind of electrical rectifier circuits. I told you. Similarly, capacitor will be taking the responsibility to produce ripple free voltage. That's why in all chopper circuits you can observe your circuits will be designed with the help of inductor and the capacitors. You can recheck now, because those two people are taking responsibility to produce ripple free voltage and ripple free currents. Got it? So here they haven't told any information, they haven't given about the type of the load or nature of the current in the output side. So by default, you have to assume that the output current is continuous. When the output current is continuous, then the average output voltage of the full bridge converter will become 2 Vm by pi cos alpha only. Okay, these things are by default. Fine. So if you go ahead with the full converter, bridge converter, we are actually we are discussing about the full converters only, but this is bridge converter. When we are taking bridge converter, what is the expected maximum power? As usual, same V naught average, that too I need maximum value into I naught average. Yes or no? Yes, sir. So the current that can be handled by the thyristor, there will be no changes. As usual, it is 100 ampere only, but it is a time to explore the value of V naught average. How will you do that? Sir, I know just now I found that peak inverse voltage, if I will multiply the peak inverse voltage by safety factor, that will give you what? Forward peak voltage. Yes, sir. Forward peak voltage is already given 1800. Peak inverse voltage of the bridge rectifier is only Vm. Safety factor is given 2.5. So from this, if I will divide 1800 by 2.5, I will be coming up with the 720. Undoubtedly, this value will give you the value of 720. Yes, sir. Yes, it will be equal to, what is this? 720 means Vm equal to 720. Remember here. But whereas the V naught average formula is 2 Vm by pi into cos alpha. It is same for both into 100. But as usual, the value of cos alpha we are going to maximize, that will be equal to 1. And the value of Vm equal to what? It will be 720. So 720 into 2 will become what? Automatically it will be 1440. Yes or no? If you multiply it by 2, it will be 1440. Then divided by pi. So it will become 458. Am I correct? 458 and then multiplied by 100. So such that it will become 45.833836 kilowatt. Yes, Geeta ma'am, you are correct. So it will be 45.836 kilowatt. Fine, sir. What is the difference between this and this? See, if I will take power that can be handled by the converter in case of midpoint, we got 22.918. 22.918. Just multiplied by 2, you will be getting 45.836. Yes or no? Because the basic difference, let me tell you. Now you no need to do this much of calculation. Basically, we have observed that the peak inverse voltage of the midpoint converter is 2 times of maximum voltage, whereas the peak inverse voltage of the bridge converter is only Vmax. So if you observe these two, here it is twice, whereas it is only Vmax. Under this situation, if you are trying to calculate the value of power handled by the midpoint converter and power handled by the what I can say bridge converter, what kind of relation you will be getting? Just to see, under this situation, it will give you the power handled by the bridge converter will become twice of power that can be handled by the midpoint converter. See guys, it is just power that is traveling through It is not only output power. Handling in the sense that power is traveling through converters also. So that is power handled by the midpoint converter and bridge converter. It will become twice. Okay. So that's what we have been observed from the given question. Now you might learn these things. I know these things are new for you. That is the peak inverse voltage and safety factor. So whatever the things that you guys are observing new, not for all, some of you, just make it hints and make it as a notes. Keep it in your short notes. Revise பண்ணும்போது இதெல்லாம் just ஒரு time go through பண்ணிக்கலாம். Right? Sure. Now let me bring the next question here. Yes. So the given question is a single phase, as I said, a single phase voltage control, that is a single phase fully controlled voltage converter is connected. A single phase voltage controlled is connected to supply voltage Vs equal to what they told is 200 times of sine omega t, whereas f equal to 50 hertz. It is given. Okay. Next, its output is fed to a load, purely resistive load, right? It is connected once again. It is its output purely resistive, whereas they told the value of R, it is equal to 20 ohm. That is also given. Okay, sir. Now firing angle alpha is given as 90 degree. Okay. What is the power that can be delivered to the load? Power delivered. It is not power handling. Output power எவ்வளோன்னு கேட்டிருக்காங்க. Power delivered to the load is dash. Take your time, drop your answer in the comment section. I'll be waiting for next 2 to 3 minutes you can take, but do it fast. Do it fast. I'm repeating, do it fast. Be conscious. Step by step போடும்போது don't be late. அப்படியே உட்காந்துட்டு கதை யோசிச்சுட்டு இருக்காதீங்க, என்ன வரும் அப்படின்ற ரிசர்ச் பண்ணிட்டு இருக்காதீங்க. Maximize your speed. You guys got the answer? Take your time, no issues. One more thing I just wanted to convey. Listen guys, listen. In the last question they asked power handling, yes or no? Handled power in the sense that time I just went up with they have given maximum peak inverse voltage, and then I have just taken V0 average, and we have taken the thyristor average current. Yes, I do remember that. These things you have to use these things only. They are asking what is the power that can be handled by the converters. If they are asking, because to know the converter power we have to go up with the average. What is the maximum voltage that will be blocked by the thyristor, and what is the current that can be flow through the thyristor, because that same things will be available in the output port. So if they are asking power handling or power that is flowing through the circuit, then you must go up with the average values. Let me repeat one more time. Basically where we will be using this V0 average and I0 average. தைரிஸ்டரை பற்றி பேசியிருந்தாங்க அப்படின்னா, தைரிஸ்டரால் எவ்வளோ பவரை ஹேண்டில் பண்ண முடியும்னு சொல்லியிருந்தாங்க அப்படின்னா, நம்ம தைரிஸ்டரில் வந்து ஆவரேஜ் ஆர்எம்எஸ் வோல்டேஜை பற்றி நம்ம எப்பயுமே பேச மாட்டோம். What is the expected, அது எவ்வளோ மேக்ஸிமம் வோல்டேஜ் வந்து பிளாக் பண்ணும் அப்படிங்கிறத பற்றி தான் பேசுவாங்க. அப்போ அந்த வோல்டேஜை மேக்ஸிமைஸ் பண்ணுறதுக்காக லெஃப்ட் ஹேண்ட் சைட்லேயும் ரைட் ஹேண்ட் சைடில் நம்ம என்ன பண்ணுவோம் அப்படின்னா வாட் கேன் பி தி மேக்ஸிமம் எக்ஸ்பெக்டட் வோல்டேஜ் தட் கேன் பி ட்ராப்டு அக்ராஸ் தி தைரிஸ்டர் தான் நம்ம எஸ்டிமேட் பண்ணுவோம். ஃபார் தட் we will be going up with the average values. பட் அவுட்புட் பவரை பற்றி மட்டும் ஸ்பெசிஃபிக்காக பேசுகிறாங்க அப்படின்னா, so when the moment they are talking about only specifically output power, what is the expected output power absorbed by the loads, இந்த மாதிரி பேசுனாங்க அப்படின்னா, if they are talking about only loads, for identify the difference between these two. In the last case we have identified the power that can be handled by the converters. At the same time that power is also flowing through the loads. அப்போ நம்ம என்ன பண்ணோம், we have taken with the V0 average, and I also told you that you can't take output current directly because the power that you are calculating here that should be flow through the converter also. Output current வச்சு நம்ம டைரக்டா calculate பண்ணோம் அப்படின்னா that current cannot be handled by the thyristor. Your thyristor may leads to damage. Hotspot region will increase, temperature will increase, it may leads to reduce the lifetime of the thyristor, soon it will get damaged. So it is not possible to go up with the output current. We should go up with what is the current that can be handled by the thyristor. That's why I have taken average current and voltage directly. When the moment they are talking about only loads, what should I do, sir? If they are specifically asking you, see that two case here they are talking about resistive load, purely resistive load. In that case, what you have to do is, in order to know the total power that can be absorbed by the load is, given it is purely resistive load, there will be no any inductance. If there will be no any inductance, your output current will not be ripple free. Yes or no? You can try to achieve that. Anyway, full wave rectifier நாலே உங்களுக்கு output வந்து continuous-ஆ தான் வரும். But you cannot avoid that ripple freeness. You should not avoid that ripple free values. What should I do, sir? What you are trying to mean? When we are having purely DC value, then there will be no issues. We can directly calculate the value of output power with the help of DC parameters. But when they are giving it is purely resistive load, it's clearly indicating that the output should not be continuous. Now starting like this output current will become ripple free only when they are giving RL load. Two cases. Output வந்து எந்த load பத்தியுமே பேசல அப்படின்னா by default you can assume that the output current is ripple free. நான் சொன்னேனா இல்லையா? Otherwise they will give you, அவங்களே கொஸ்டின்ல வந்து கொடுத்திருப்பாங்க this load RL load but ripple free அப்படின்னு சொல்லியிருப்பாங்க. RL load பத்தி கொடுத்திருந்தாங்க அப்படின்னா ரெசிஸ்டிவ் லோடு அவங்களே கொஸ்டின்ல மென்ஷன் பண்ணதுக்கு அப்புறம் now you should think, சார் கொஸ்டின்ல கொடுத்திருக்கிறது ரெசிஸ்டிவ் லோடு தான், ரெசிஸ்டர் will not take any responsibility to produce ripple free current. It can't do. First of all, you all know that. Then how would I get the continuous current, the ripple free current in the output side? Sir, it is not possible. So when you are not having the ripple free current in the output side, how do I calculate the maximum power that can be absorbed by the load? Under this situation, you are supposed to go up with the RMS power only. Okay, you must go up with the RMS voltage. You should not directly calculate because output is not ripple free. Ripple free illa appadina neenga direct constant value assume panna mudiyadhu. So you have to calculate what the output power is not V0 RMS square by R you can use, or I0 RMS square into R. But it is very easy to calculate V0 RMS square by R. Remember? So அப்போ நம்ம full converterல என்னென்ன விஷயங்கள்லாம் புதுசா கத்துக்கிட்டு இருக்கோம் அப்படின்னா, first thing I have already told you, your output current will become ripple free, sir. Yes, this could be possible when I have told the point. Questionல எந்த ஒரு டேட்டாவுமே கொடுக்கல, no data about load and output current, about load or output current. ரெண்டுமே இருக்கக்கூடாது, லோடும் இருக்கக்கூடாது and output current இருக்கக்கூடாது. By default you can assume under this case your current will be ripple free, continuous current னு assume பண்ணிக்கலாம். One case. Second case, given it is, but they have mentioned that the load is RL load and the value of inductance is large, because there are two cases. In RL load you will be getting discontinuous conduction also. Inductance value is large in the sense what? It will be producing a ripple free current only. That is another clue they will be giving. In some cases I told now output current directly they will give you the output current is ripple free. Now for the other cases you have to cross check whether the current is ripple free or not. That things will be taken care by you people only. Do remember that. For other loads also, you can also consider RLE load. I told you RLE load. There also inductor will take the responsibility to produce the continuous current. If they are giving RLE load, where also if the inductance value is very large, then automatically it will lead the circuit. This inductor will take the responsibility to produce the continuous ripple free current. So it is very important to observe the nature of the load. You cannot directly assume everywhere. Every time I am repeating this, you can use these things only when the current is ripple free. But it is clearly given that they are taking purely resistive load in the sense you should think about it. Okay, sir. Then the circuit will be having some ripple in nature. Output side is not purely DC. Ripple means in order to calculate the total ripple, you must go with the RMS voltage. So that is the formula is V naught RMS square divided by R. What is the value of what is the formula to calculate the V naught RMS? How many of you know for single phase full bridge rectifier with the resistive load V naught RMS formula? Yes, I hope I am remembering. Let me try to drop it. It will be root Vm divided by root 2 by pi, root 2 into pi, root 2 times of pi, right? Into, in bracket, you can keep all other parameters. No, pi should not be under root. See, 1 minute, guys. I to forget very long gap. I'm just doing by myself now. Yes, I have recaptured it. Vm divided by, it should be root 2 into pi. Then in bracket, we can substitute, it is pi minus alpha plus sine 2 alpha divided by 2 whole power 1 by 2. I hope I am correct. So it is pi minus alpha plus sine to alpha by 2 whole. Yes, this is correct formula. This is the formula to estimate the value of V naught RMS. See, they clearly told that the value of alpha is 90 degree. Here you should substitute in radiant. For the sine, you no need to keep radiant value. Degree itself, you can keep 90, it will give you the value of answer. But anyway, here 90, 2 times of 90 will be 180, sine 180 will be 0. You all know. So this factor will dice. So remaining what you will be getting Vm divided by root 2 into pi. Pi minus, see, pi minus pi by 2 will give you pi by 2 under root. So I can substitute root pi divided by root 2. That is what we will be getting here. Root of pi by 2 can be written root pi by root 2. So root 2 into root 2 will become 2. I can write Vm divided by, see, this pi can be written as root pi into root pi. 1 root pi will be cancelled. So Vm divided by root pi into 2 now. This is the final answer. Vm by 2 into root pi. What is the value of Vm now? Do you know the value of maximum expected voltage? Let's see. I haven't observed the question. See, given it is instantaneous voltage. Yes or no? This is the expression of instantaneous voltage. From here we can collect the maximum voltage. So Vmax will be 200. Directly we can substitute the value. 200 by 2, that will give you 100 by pi. Finally, 100 by root pi, sorry. So now, if you take pi, you have to take root, then reciprocal multiplied by 100. Yeah, it will be equal to 56.418. We got the V naught RMS. Now output RMS power, output delivered power. It will be equal to, just to square this voltage divided by resistance. V naught RMS square divided by R. V naught RMS square divided by R. So this will be equal to 3183.09. This is V naught square divided by resistor value they have given now. Yes, that is 20. So just divide this value by 20. You will be getting 159.154 watts. Yes, you guys are correct. This is the correct answer. See, in the single phase full converter and the RMS voltage is little important. A little, especially this formula. இப்போ நம்ம சால்வ் பண்ணோம் இல்லையா இதில் தான் வந்து மோஸ்ட்லி ஆர்எம்எஸ் வோல்டேஜ் வச்சு கேட்குறாங்க அப்படின்னா இந்த ஃபார்முலா வச்சு தான் கேட்பாங்க. That's why I'm covering this here. Okay, just keep these things in your mind. Chalo sir. Shall we go ahead with the next question? Let me bring the next one. A three-phase Next question. A three-phase fully controlled converter is feeding a power into a DC load. Okay, three-phase fully controlled converter is feeding power. Just note down the question. Is feeding power to DC load. Okay, sir. That is the first data they have given. Now in the bracket they told that current is constant. Okay, let me write like this. Output current is constant. This data is given by them. Okay, sir. And the value of the output current also given. The value of output current I naught is equal to 200 ampere. Current is constant and its value also given. The RMS current in ampere through each thyristor of the converter is dash. The RMS value of the thyristor current is dash. Each thyristor current. ஒரு individual thyristor எடுத்துக்கிட்டீங்க அப்படின்னா அதில் எவ்வளோ RMS current flow ஆகும்னு கேட்குறாங்க. Three phase fully controlled converter. I know many of you guys know the answer for this, so don't take much time. Do it fast. Drop your answer in the comment section. உங்க எக்ஸாம்ல என்னென்ன மாதிரிலாம் கொஸ்டின் கேட்பாங்களோ தட் ஆல் திங்ஸ் ஐ எம் கவரிங் ஹியர். ஸோ இந்த நீங்கள் மற்ற ஃபார்முலாலாம் உங்கள் மைண்டில் இருக்கோ இல்லையோ இங்கே நான் நடத்துறதுல என்னென்ன ஃபார்முலாஸ் வருதோ அது எல்லாத்தையும் மைண்டில் கொஞ்சம் ஸ்டோர் பண்ணிக்கோங்க. சார் நீங்கள் எதனா டெரைவ் பண்ணி போட சொன்னீங்க, நான் தான் சொன்னேன். டெரைவ் பண்ண கற்றுக்கோங்கன்னு தான் சொல்கிறேன். ஐ எம் நாட் ஃபோர்ஸிங் யூ டு மெமரைஸ் எனி திங் ஹியர். எக்ஸாமில் டைமை சேவ் பண்ணுறதுக்காக திஸ் திங்ஸ் யூ கேன் கீப். I am not going to give 1000 formula. Store it in your mind. Keep these things such that easily you can directly drop the formula and bring the answer. At the same time, understanding the waveform pattern also very important. Geeta ma'am, no. What is the answer? There are so many people are in the live, but nobody is giving the answer. I just wanted to know the answer. Thyristor average current, RMS current எப்படி calculate பண்ணுவீங்க? நம்ம இப்போ single phase full bridge-க்கு நம்ம பார்த்தோம். என்ன பார்த்தோம்? When the output current is continuous, we saw in case of single phase full bridge converter, the average value of the thyristor current will be equal to average value of the output current divided by 2. Similarly, we saw thyristor RMS current will be equal to output RMS current divided by square root of 2. We have estimated this. So these two formulas are valid for single phase fully controlled bridge converters. Fully controlled converters, single phase fully controlled converters. That things we saw. Similarly, explore the same thing for three phase fully controlled converter. What is the answer? 115.47. Good. Okay, chalo. Let me drop the answer now. It is very easy. Listen, when you are focusing three-phase rectifiers, basically what will happen is, in case of three-phase full converter, they told that output current is constant. Output current is constant. In case of full converter, we will be having three legs. You all know, leg number 1 will carry 2 thyristor, then leg number 2 will carry 2 thyristor, leg number 3 will carry 2 thyristor. So each and every thyristor என்ன அப்படின்னா ஒவ்வொரு 120 டிகிரிலையும் வந்து ஒரு பேர் வந்து கண்டக்ஷன்ல இருக்கும். For each and every 120 degree, one pair of thyristor will be in conduction, or I can say one thyristor will be in conduction, because I don't want to talk about the pair at all. One thyristor will be in conduction for 120 degree, I can say, period of the thyristor, whereas the overall period of the one complete cycle is 360 degree. Yes or no? In order to complete one complete sinusoidal waveform, we will be taking 360. Output la vandu நம்ம என்ன பண்ணோம், our focus should be up to 360, whereas through the thyristor we are receiving only current up to 120 degree. Output la அவங்க என்ன சொல்லியிருந்தாங்க, They have taken the output current. They told that output current is ripple free, constant current அப்படின்ட்டு அவங்க சொல்லியிருக்காங்க. So that current will be repeated. So if you observe 0 to 360 degree, you will be having constant current in the output side. Same current will get repeated after 360 degree also. But whereas this current will be for the first 120 degree, this output current you can receive for first 120 degree, you can receive the output current with the help of thyristor T1 and T2. After that, next 120 degree, thyristor T3 and T4. After that, next 120 degree, thyristor T5 and T6. Like that, it will be continued. See, this is not mandatory. I am just telling the sequence. 2 to thyristor will be in connection for each and every 120 degree, like that. So if you observe from this, I can say, if you want to estimate, if you want to draw the waveform for only one thyristor T1 alone, then this current will be output current. I am comparing output current to thyristor T1. Thyristor T1 will carry this same amount of output current only for 120 degree. After 120 degree, other thyristor will take the responsibility to carry this current. So now I can write like this. See, the average value of the thyristor current. Average value of the thyristor can be written as, what I can say, area by time period. I have already told you, area by time period, whereas the time is fundamental time period. Area means thyristor will be carrying the output current only for 120 degree, whereas the overall time period is 360 degree. Area, it is rectangular period. Width into height. Width is 120, height is high naught. See that if you cancel it, it will become I naught by 3. So the average value of the current carried by the thyristor, this can be written as average current carried by the thyristor. In case of 3-phase fully controlled rectifier, I can say I naught average. You can take average value of the output current divided by 3. Average value of output current equal to I naught maximum. You can directly substitute. That is the relation between them. We can see that here, this is output, average value of output current only. Similarly, if you want to focus, RMS also will become same only. Output current in the restriction kadayadu. How will you calculate the value of RMS current if you want to know the value of RMS value? I hope you remember what you have to do. You should square the magnitude multiplied by the, let me solve in the next page. The thyristor RMS current should be equal to, RMS means root mean square value. Up average value of magnitude square panni, that will be converted into RMS, right? Into what? Time period. Thyristor time period, overall time period, and you must keep all this parameter under root. Now if you cancel it, degree will get cancelled 3 times. Then I naught square you can take it out. It will become RMS output current. Average, RMS, maximum, all will be same here, divided by root times of 3. So the thyristor average current will be equal to average value of the output current by 3. Thyristor RMS current equal to output RMS current divided by 3. Both will be same only, right? Average and RMS you can directly substitute. That is given as 200 ampere. You can substitute that value here. You will be coming up with the same answer. Now what is the question? They told output current is given. Thyristor RMS current is what? Just to substitute here 200. You will be getting average current. Question is RMS. Then substitute that 200 here. Output current is continuous. So I naught average, I naught RMS, both are same. Don't get confused. Sir, how can you substitute the same value for both average and RMS? Since that current is DC, that too ripple free. So all values are same there. Don't get confused. DC பொறுத்த வரைக்கும் RMS average எல்லாமே same value தான் வரும். So you can substitute that value here. You'll be. So what is the expected answer? 200 by, you should take root 3. You'll be getting 115.47 ampere. I hope you guys also got the same one, right? Yes. Chalo. Let us go ahead with the next question. I will be dropping here itself. One minute. Yeah. See, the question is the single phase dual converter. They are talking about single phase dual converter is operated from is a single phase dual converter is operated from 240 voltage, comma 50 Hz frequency, that is given. Under the load resistance value they have given load resistance R, that is equal to 10 ohm. Okay sir. The circulating inductance is, in dual converter there is one inductance is called circulating inductance. That value they have given, that is 50 millihenry. Okay sir. The firing angle alpha, dual converter, there will be two conductions, one is from right to left, another one is left to right. So alpha 1 they have given 60 degree and alpha 2 also given 120 degree. Okay sir. Now the question is, what is the peak current carried by the converter 1? Peak current carried by the converter 1. So dual converter means we will be having, so power will be circulated from primary to secondary and secondary to primary. That is called a dual converter. So we will be having two converters here. First power will flow from here to here and then power will come back from here to here. When power is going from here to here, they have given the alpha as 60 degree. When it is coming back, they have given one more, that is 120 degree. Now what is the peak current carried by the converter 1? That is the first converter. Do you have any rough idea for this dual converter? If you have any rough idea, you can try to solve this question. If you don't have any idea, no issues, I will be helping you. Okay, there are some things to know from dual converter. I will be dropping those things now. Don't worry. Okay. I hope majority of you might not know the formula to handle this question. Let me just give you the formulas. Do remember. First of all, when they are asking the peak value of the converter 1, the converter 1 used to carry two things. One is the peak circulating current. I can say one current is called peak circulating current. Maximum current that is circulated from converter 1 to 2 or 2 to 1. So that is peak circulated current. இப்போ இங்க ஸ்பெசிஃபிக்கா கரண்ட் ஒன்னு தானே கேக்குறாங்க, current converter 1. So first you have to calculate peak circulating current. First calculate that value, and then second thing you have to observe the maximum peak current that is flowing through the load. Peak load current, two things we have to estimate. That is the overall peak current carried by the converter 1. Similarly converter 2 பத்தி கேட்டாங்க அப்படின்னா peak circulated current plus maximum current carried by the load. Opposite side la neenga calculate பண்ணனும். Okay sir. Now peak circulating current, what is the formula to calculate the peak circulating current? So this is very important. 2 Vm by omega L into 1 minus cos alpha. They are talking about converter 1. So I am writing the formula for peak current 1 plus maximum load current வேணும் அப்படின்னா என்ன பண்ணணும், maximum peak voltage divided by load value resistor. That's all. Now the value of alpha is already given, that is 60 degree. Maximum voltage given, it is RMS voltage, so 240 into root 2 you can substitute. Frequency omega, that is 2 pi f. F value is given as 50 Hz. Inductance L, circulating inductance, that value also given, that is 50 millihenry. You can directly substitute 50 into 10 power minus 3. So this is peak circulating current, so its correspondent inductance is circulating inductance. You can keep omega LC. LC means circulating inductance. Okay, so that is 50 into 10 power minus 3. Just that's all. Substitute all the values. Maximum voltage, once again here also it will be 240 into root 2 only. Resistor value is given already, that is 10 ohm. That's all. Substitute all the parameter, you will be getting the value of peak current. And just to do remember these things, just make it as a small note, that will be sufficient. Okay. Chalo. Let us go ahead with the next question. Now I am dropping the next question here. The next question what the given it is a single phase full converter. A single phase full converter is operated with a symmetrical angle control. Is operated with a beautiful question. It is operated with a symmetrical angle control. What is the meaning of this? Symmetrical angle control. It's a new word, right? For you people, not for all, some of you. Symmetrical angle control. The load current with an average value of IA is continuous. So what they are telling is load current is continuous simply, that is the given. Output current is continuous. So the ripple content is negligible and the conduction angle alpha. No, 1 minute. That is firing angle. They are different. Conduction angle is given. Thyristor conduction angle it is. Conduction angle is given as pi by 4. Okay, sir. Next, the peak input voltage is, they have given maximum input voltage, that is called peak input voltage, right? So the peak input voltage is given as 185 volt. Okay, sir. Now, what is the expected value of output RMS voltage? That's all. I am repeating the question one more time. A single phase full converter is operated with a symmetrical angle control and the output current is continuous ripple free. And the conduction angle is given as pi by 4. Peak input voltage is 185. Calculate the output RMS voltage for the single phase full converter. That's all. That's given. What can be the expected answer for this question? Just try. Symmetrical angle control. Do you have any rough idea for this? You can try. ஏதாச்சும் ஒரு விஷயம் தெரியலனா try to learn it, no issue. Any idea? I'll be waiting. You can take 2 to 3 minutes. Try to drop the answer. Got the answer? Nobody? No worries. Let's see. Listen. Sir, first of all, what is this symmetrical angle? Just think about it. நீங்க எதுவும் மெமரைஸ்லாம் பண்ண தேவையில்ல அண்ட் புதுசாக கற்றுக்கவும் தேவையில்ல. வாட் இஸ் தி மீனிங் ஆஃப் சிமெட்ரிக்கல் ஆங்கிள் கண்ட்ரோல்? அட்லீஸ்ட் டெல் மீ தட். Anybody? Okay. So now I am giving the answer. Listen. Symmetrical angle control அப்படின்னா degree will be same at all points. What you are trying to mean, sir? What I mean is, suppose if you are taking one waveform, let us see. The input waveform is purely sinusoidal. It looks beautiful. Let me draw the waveform. Okay, sir. The input waveform is purely sinusoidal and it is going like this up to 360 degree. Let us keep our attention with the output waveform. Under this situation, if suppose given it is, if they are using symmetrical angle control, given it is, we are going to use symmetrical angle. You might heard this word in signals and system. What is the symmetric? Symmetric means it should be even everywhere. Now in our question they told that let me break 0. Now take 45 degree, because the firing angle is given as pi by 4. Pi by 4 means you can divide. Let me take this. See, pi equivalent value is 180. If you divide 180 by 4, you'll be getting 4 times of 4 will be 16. Remaining will be 2. If I will cancel it, I will be getting 45 degree equivalent value. So we are triggering the circuit at 45 degree. First 45, from 0 to 45. We are starting at 0 degree. For at 45 we are triggering. From this, it will be continuous its conduction for the next 45. 45 plus 45 will give you 90 degree. So you can go up to 90 degree. Let us take. Let me remove this. Wait. Don't worry, I will be explaining everything. Just be patient. Okay, sir. Next 95. Again take one more, 90 degree. One more 40 will give you 135 degree. Yes or no? 90 plus 45. Next 45. 135 degree. Again, next 135 plus 40 will be equal to 180. Yes, sir. 180 plus 40, that will give you 225. 225 plus 45, that will be giving 270 degree. Again 270 plus 45, that will be 315. 315 plus 40, that will be equal to 360 degree. Sir, எதுக்கு இது 45 break பண்ணிட்டு இருக்கீங்க? I just wanted to know the symmetricity of the circuit. I just wanted to show you how that circuit will be showing you the symmetric nature. இது எப்படி வந்து இங்க symmetric-ஆ இருக்கும் அப்படின்னு பார்த்தீங்க அப்படின்னா, first suppose if it is in conduction, இங்க வந்து இப்போ 45 டிகிரில வந்து அது conduction ஸ்டார்ட் பண்ணி, if it's continuous conduction up to 90 degree வரைக்கும் conduction வந்து continuous பண்ணிருக்கு அப்படின்னா, after திரும்ப என்ன பண்ணும் அப்படின்னா, it will leave a 45 degree gap. ரெண்டு பக்கமும் என்ன பண்ணும் அப்படின்னா, it will be symmetric in nature. 0ல இருந்து 180 குள்ள if it is conducting for 45 degree, then it will be repeating again. 180ல இருந்து 360 குள்ள it will be repeating the nature. Again it will be continuous its conduction for one more 45 degree. அதே duration ல continue பண்ணும். That is called symmetric. If you observe the positive sinusoidal cycle la enna pattern vandirukko adhe waveform second pattern layum varum from 180 la irundhu 360 varaikum. Okay, so basically here they have given wrong answer. You can take some other value, it will be good. Let us take 5 by 3. 5 by 3 equal to 60 degree. Conduction angle on the, let us increase a little. You know, 45 degree எடுத்தோம் அப்படின்னா I cannot bring the symmetric. Symmetric angle control can be done, right, easily. உங்களுக்கு understand ஆகணும் அப்படின்றதால I have taken 60 degree. இப்போ 60 degree நம்ம எடுத்துக்கிட்டோம் அப்படின்னா what will you observe? Let me remove these things, basic things. Don't think too much, nothing to bother. I just wanted to explore it in a proper way. It can be done. 60 degree easy உங்களுக்கு புரிஞ்சிரும், அதனால I am taking that. See, first I am taking 60 degree, next conduction up to 180 120, then again 60 degree break, 60 degree break. It will be start from 0, first 60, 60 plus 60 120, 120 plus 60 180, 180 plus 60 240, 240 plus 60 300, 300 plus 60 360. That's all. அப்போ இதில் எப்படி சார் சிமெட்ரிக்காக வரும் அப்படின்னா, ஃபார் அன் எக்ஸாம்பிள் 60 டிகிரியில் வந்து நீங்கள் ஃபயரிங் ஆங்கிள் ட்ரிகர் பண்ணீங்க அப்படின்னா திஸ் வேவ் ஃபார்ம் என்ன பண்ணோம் அப்படின்னா நெக்ஸ்ட் 60 டிகிரிக்கு வந்து இட் வில் கண்டினியூஸ் இட்ஸ் கண்டக்ஷன். தென் வாட் வில் ஹேப்பன், அகைன் இட் வில் லீவ் அ கேப். லெஃப்ட் சைடில் 60 டிகிரி விட்டுருக்கு, ரைட் சைட்லையும் 60 டிகிரி விட்டுரும். ஓகே சார், அகைன் இஃப் யூ அப்சர்வ் ஆஃப்டர் 180 டிகிரி சேம் சைக்கிள் வில் கெட் ரிப்பீட்டட். First 60 degree there will be no conduction. For the next 60 degree, you know, output waveform வந்து நம்ம என்ன பண்ணுவோம் அப்படின்னா we will be bringing positive only. Full converter. Input negative இருந்தாலும் outputல polarity நம்ம reverse பண்ணுவோம். Again next degree there will be no conduction. Now if you observe the pattern, this is called symmetricity. If you observe in the first 180 degree from 0 to 60 degree, from 0 to 60 there will be no conduction. Then the waveform will be continuous up to 120 degree. Should be pakka. You have to draw it in a proper way. Okay, so it will be 120 degree we have observed the conduction. Then for the next 60 degree there will be no conduction. This is first 180. Again after 180 first 60 degree there will be no conduction. Then again same waveform, nature of the waveform will be remain same. For only 60 degree conduction period should be 60. நீங்கள் எப்படி இதை வரையணும் அப்படின்னா 180 ஃபர்ஸ்ட் 180 டிகிரி எடுத்துக்கிட்டிங்களா, 180 டிகிரியில் இப்போ அவங்க 60 டிகிரி கண்டக்ஷன் கொடுத்துருக்காங்க அப்படின்னா 60 டிகிரிக்கு வந்து ஃபர்ஸ்ட் வரைஞ்சிருங்க. 60 டிகிரியில் ஸ்டார்ட் ஆகிட்டு அடுத்த 60 டிகிரிக்கு அதை வரைஞ்சி முடிச்சுட்டு அதே வேல்யூ இதே மாதிரி அடுத்த 180 டிகிரி சேம் பேட்டர்ன் வரணும். இங்கே எப்படி நீங்கள் வரைகிறீங்களோ இப்போ இங்கே 0லேருந்து 60 டிகிரி 0வா, அப்போ இங்கே 0லேருந்து 60 டிகிரி 0 அண்ட் தென் யூ கேன் ட்ரா தி வேவ் ஃபார்ம். இங்கே எப்படி இருக்கோ அதே பேட்டர்னில் இங்கே வரும். இங்கே கண்டக்ஷன் எது வரைக்கும் கண்டினியூ ஆகுதோ அதே மாதிரி இங்கேயும் கண்டக்ஷன் will be continuous. That is how the circuit will be. This is called symmetric angle control. Basically it is called a symmetric angle control. According to the given data I have taken this value of 60 degree. Just 45 pota I cannot divide it properly, so it's to confuse you. Don't worry, இந்த மாதிரி கொஸ்டின்லாம் அவங்க கொடுத்தாங்கன்னா கிளியரா ஐடென்டிஃபை பண்ணிருப்பாங்க இது எப்படி இந்த மாதிரி பிரேக் ஆகும்ட்டு. நீங்க ஈஸியா இதே மாதிரி பிரேக் பண்ணலாம். Fine sir. Now how do I calculate the question is what? Output current is continuous. V0 RMS value is dash, right? Yes. Let us explore. What is the basic formula to calculate the V0 RMS? V0 RMS equal to, I have to take as usual. இங்க என்ன கேட்டிருக்காங்க, ரூட்ல இன்டெகிரல் இருக்கு இல்லையா, so let us take 1 by time period t integral of magnitude square with respect to d omega t. This is RMS under root. So here what is the total time period? Let us see. 0 ல இருந்து 180 degree வரைக்கும் என்ன waveform வருதோ same waveform will get repeated after 180. Again it will be repeated. So period should be considered only 180. Why? I told you. You can consider 360 also. You can consider 180 also. When it will be possible? If your nature of the waveform for each and every 180 degree, if you are observing same waveform, then you can consider only 180. Suppose if the nature of the waveform is first 180 degree it is like this, after for from 120 to 360 it will be like this. Now after 360 same waveform is repeated like this. If you go like this, first see there For each and every 360 you are observing same pattern. So in this case you should consider 360 degree. Second case, first 180, second 180, third 180, fourth 180. If all the pattern are same, for each and every 180 if you will have the same waveform, then you should consider the period as 180 only. It is not only for 180, 360. Suppose that for each and every 60 degree I am getting same waveform, then you can consider the period as 60 degree. So it depends on the nature of the waveform. After how many angle the waveform is getting repeated again and again. Okay. So here the fundamental time period I am going to consider only pi, because after pi same period is getting repeated after 180. And here what is the duration from 0 to pi? If you observe, this waveform is existed from only 60 to 120 degree. How will you convert into radiant? 60 into pi by 180, it will be equal to pi by 3. Similarly, 120 into pi by 180, it will be equal to what? 2 times of 60 will be 20, 3 times of 60 will be 180, it will be equal to 2 pi by 3. So the period will be pi by 3 to 2 pi by 3. Nature of the waveform is sinusoidal. Yes or no? We have injected sinusoidal only, but that waveform we are observing in the output side only from 60 to 120 degree d omega t whole power 1 by 2. Okay, sir. So from here 1 by pi, if you square this is will become Vm square. You can take it out. Sin square omega t can be written as 1 minus cos 2 omega t divided by 2. Sir, why are you writing like this? Because we cannot directly integrate sin square omega t. So I am writing its alternative format in order to complete the integration. Sin square omega t நம்மளால அப்படியே integrate பண்ண முடியாது. Now it is very easy for us. You can take this Vm outside, Vm square root ல இருந்து வெளியில வந்துரும். But that pi you can't take. You can write like this Vm by root pi in bracket. That 1 by 2 இருக்கு இல்லையா, 2 ஐ வெளில எடுத்துக்கலாமா? That will also become root 2 only. So root of 2 into pi will come. Fine, sir. If I integrate 1 with respect to omega t, you will be getting omega t minus cos omega t will give you sin 2 omega t. Internal differentiation will give you one more 2. Yes. Now we know the limits. It is going from pi by 3 to 2 pi by 3. Remember, all these parameters are lies under root. Let us reduce this. So we got Vm upon square root of 2 into pi. Okay, sir. Here, what is the upper limit? For the omega t, upper limit is 2 pi by 3, lower limit is pi by 3. I can directly write 2 pi by 3 minus pi by 3. Omega t limits are over. Minus sin 2 omega t. Let us continue with this. See, if I replace omega t by 2 pi by 3, you will be getting sin. Already one more 2 is there. So 2 into 2 pi by 3 will become 4 pi by 3. So sin 4 pi by 3 minus of sin, again pi by 3 we have to substitute. So sin 2 pi by 3 divided by 2. So what we will be getting here is sin 4 pi by 3 minus sin 2 pi by 3. I know there is one common factor, that is 1 by 2. And this all terms are lying under root. Exactly, sir. So it will be Vm divided by square root of 2 into pi. 2 pi by 3 minus pi by 3 will give you pi by 3 minus 1 by 2 into what is the value of sin 4 pi by 3? It will be equal to 0.0523 minus, if we take 1 minute guys, yeah, actually this is not 0.05, I am getting 0.073. Again, if you take 2 pi by 3, again I should take, I'm making some mistake here. Actually we have to substitute degree here. 4 times of pi is what? Anyone? Pi is equal to 180 degree, right? So let us reduce this. 4 into 180 by 3, it will be equal to what? 60. 4 times of 60 will be 240 degrees. So its equivalent value will be 240. If you take 240 for sine, I will be, this is actually minus 0.866. ஏன்னா சைனுக்கு நம்ம டிகிரியில் சப்ஸ்டிட் பண்ணாதான் that will give you equivalent radiant value, right? 2 pi அப்படின்னா 360 by 3 னா 120. So now you can substitute 120. If we take sine, you'll be getting 0.866. Now see there, both are minus 0.866 minus 0.866. So 2 times you can multiply. Then already one more minus is there outside. Minus into minus will become plus. Again it will be divided by 2. So what I will be getting here is Vm divided by square root of 2 pi. Here pi by 3 minus 0.866. I know it all lies under roots. Now it's time to subtract pi by 3 minus 0.866. Is it minus or plus? It should be plus, no? See, already minus into minus it will become, guys, it is plus. Forgive me. Just change the polarity. Now pi by 3 plus 0.866. You will be getting 1.913 and then take square root. So finally, I am getting Vm into 1.383, its equivalent value, divided by root of 2 into pi. What is the maximum voltage? Any data about this? Yes, it is given. It is 185. So 185 into 1.383 upon root of 2 into root of pi. That's all. That is Manilama. So it will be into 185 divided by, so I will be getting 102.084 volt. Okay, what is this? So we were successfully calculated the value of V naught average. Yes. So today you have learned one more beautiful factor, the meaning of symmetrical angle control. Guys, it is not a new thing. Listen, first of all, nothing is there. I also understood from the observations only. When I was solving these kind of questions, symmetrical angle control, it will be symmetric in nature. 0 to 180 குள்ள என்ன மாதிரி நேச்சர் வருதோ அதே நேச்சர் ஆஃப்டர் 180 டிகிரிக்கு அப்புறமும் வரும். அதே மாதிரி இப்போ 60 டிகிரியில் அது கண்டக்ஷனை ஸ்டார்ட் பண்ணுது அப்படின்னா அடுத்து என்ன ஆகும்? 60 டிகிரிக்கு அதோட கண்டக்ஷன் வந்து கண்டினியூ ஆகும். இட் ஷுட் பி சிமெட்ரிக். ரெண்டு பக்கமும் சிமெட்ரிக்காக வர மாதிரி நம்ம கொண்டு வரணும், அவ்வளோதான். இப்போ 0லேருந்து 180 வந்து இதோட நேச்சர் 60 டிகிரி கண்டக்ஷனில் இருக்கா, அதே நேச்சர் அதே டியூரேஷனில் அடுத்த பேட்டர்னில் ரிப்பீட் ஆகும் ஆஃப்டர் 180 டிகிரி. தட் இஸ் கால்டு சிமெட்ரிக்கல் ஆங்கிள் கண்ட்ரோல். நேம் இட் செல்ஃப் இட் இஸ் கால்டு சிமெட்ரிக்கல் ஆங்கிள் கண்ட்ரோல். Okay, I hope you all have understood what I am trying to mean it. Okay, so finally expected answer is what? So we will be getting the answer is I forget this. Yes, 102.08 voltage. Fine, sir. Now let us go ahead with the next question. The given it is a single phase full converter delivers power to a resistive load. Delivers power to resistive load. Finish, sir. Next, for a AC source voltage, supply voltage is given as 120 volt. Frequency 50 Hz and firing angle alpha equal to 45 degree. Everything is given. What is the V naught average? Expected value of V naught average. First tell me, இவ்வளோ டிஸ்கஷன் நம்ம முடிச்சாச்சோ. இப்போ இந்த லோடு டிஸ்கன்டினியூஸ் லோடா கண்டினியூஸ் லோடா? எனி ஒன் ஜஸ்ட் எனக்கு சொல்லுங்க. ஐ டோன்ட் நோ. யூ கேன் ட்ரா. அசம்ஷன்ல மட்டும் சொல்லவே கூடாது. 100% அக்யூரசி. சார் திஸ் இஸ் தி ஆன்சர். டூ இட் பை யுவர் செல்ஃப். ஃபயரிங் ஆங்கிள் கொடுத்துருக்காங்க, லோடோட நேச்சர் ஆர் லோடு அவ்வளோ கிளியராக மென்ஷன் பண்ணியிருக்காங்க. நவ் இட்ஸ் டைம் டு டூ இட் பை யுவர் செல்ஃப். எக்ஸ்ப்ளோர் தி ஆன்சர். எனக்கு ஒரே ஒரு ஆன்சர் தான் வேணும். ஆன்சர் தேவையில்ல. இது கண்டினியூஸாக டிஸ்கண்டினியூஸாக மட்டும் சொல்லுங்க. தட் இஸ் சஃபிஷியன்ட் ஃபார் மீ. I will be happy with that because at least I can understand that you all understood all the lectures so far. Is it continuous or discontinuous? I just wanted to know the answer for that. Do it first. ஒரு ரெசிஸ்டிவ் லோடு கொடுத்திருந்தா நீங்க வேவ்ஃபார்ம் எப்படி வரைவீங்க? Do it first. வேவ்ஃபார்ம் வரைஞ்சே சொல்லுங்க. Sir, this is discontinuous அப்படின்னு கூட நீங்க சொல்லலாம். And if it is it will be good if you are able to give the reason also. I'll be very happy. First answer மட்டும் சொல்லுங்க. Is it continuous or discontinuous? Do it fast. Do it fast. Geeta ma'am, discontinuous. Very good. Any other? வேற யாராச்சும் வரைங்க ஃபர்ஸ்ட் சைனசாய்டல் வேவ்ஃபார்மை வரைஞ்சி ஃபயரிங் ஆங்கிள் 45 டிகிரி நம்ம கொடுத்தோம் அப்படின்னா அவுட்புட்ல என்ன நடக்கும் நமக்கு தெரியும் RL லோடு இருந்தால் என்ன நடக்கும்ட்டு. See, நீங்க இங்க தான் எல்லாத்தையும் அண்டர்ஸ்டாண்ட் பண்ணிக்கணும்னு கிடையாது. Here I am solving only problems. நீங்க நம்ம லெக்சர்ஸை பாருங்க. I have been taught everything ஸ்டெப் பை ஸ்டெப்பாக நடத்திருக்கேன். அது தாண்டி உங்களுக்கு டவுட்டே வராது. ஸோ அன்டவுட்ஃபுல்லி யூ கேன் லேர்ன் எவ்ரிதிங். ஃபுல்லாக பார்த்துட்டு அண்ட் தென் ட்ரை இட். நீங்களே வரைங்க. ஒரு ரெசிஸ்டிவ் லோட்னா நம்ம எப்படி பார்க்கணும்? ஹவு டு ட்ரா தி அவுட்புட் வேவ், வோல்டேஜ் வேவ் ஃபார்ம், கரண்ட் வேவ் ஃபார்ம், தைரிஸ்டருக்கு எப்படி வேவ் ஃபார்ம் வரைகிறதோ, பீக் இன்வெர்ஸ் வோல்டேஜ் எப்படி கால்குலேட் பண்ணுறதோ. These things are very important. Sometimes they will be giving you generalized circuit. Another situation, it's very important to know the answer for this kind of questions. Discontinuous, good, good, very good. Any other? I don't think that I have been asked a very big question. It's a very small question. I just asked whether the output is continuous or not. Okay, fine. Yes, this output is discontinuous. You guys are correct. Why it is? Why? Because when output is purely resistive, what will happen? I'm firing at a 45 degree thyristor is triggered. So what will happen? It will simply follow the input waveform. It will be continued up to 180 degree. After 180 degree, we will not have any kind of storage element at the load side. Discontinuous conduction should appear because inductor is not there for charging and discharging. Only resistor is there. It will absorb the power and dissipate it. That's all. So after 180 degree, once again you must leave a gap 45 degree. Once again at 225 degree, one more pair of thyristor will take responsibility to produce the another waveform. This is, however, output waveform will be continuous in the output side. Yes, it's very good. You are correct. Now see there, 45 degree. Now we understood after 180 degree same waveform will be repeating. How will you calculate the V naught average? The formula to explore. First to find out the time period. I am going up to 180 degree only. Why? Because after 180 degree same waveform will get repeated. 45 equivalent value will be 4 by 4, sorry, pi by 4. Pi equivalent 180 equivalent value will be pi, and we are keeping our attention with the sin omega t. I know most of you guys know the formula directly. I am just showing you how to derive it. You can take Vm outside, it will become minus cos omega t, and the limit will be going from pi by 4 to pi. If you substitute these values, it will become Vm by pi into minus cos pi. While going up with the lower limit, one more minus will be existing, so minus into minus will be plus. You can substitute cos by pi by 4. See, here you should replace this pi by degree. 180 degree pi by 4 means it will be what? 45 degree. Yes, I hope you all know this. So now from this I can say Vm by pi into cos pi equal to minus 1. So minus into minus will become plus 1. Here once again plus, what you can keep? Cos pi by 4, right? So pi by 4 value is 1 by root 2 directly, right? Okay, I have substituted the value of alpha. Generally normal derive பண்ணும்போது in general case we will be keeping alpha here, pi plus alpha. After derive பண்ணீங்கன்னா you will be getting original formula. Wait, I will do that one also, no issue. So cos 45 means 1 by root 2, that's all. Hereafter you can do everything. இதை நீங்க generalize பண்ணணும் அப்படின்னா just replace this pi by 4 by alpha. Alpha replace பண்ணீங்க அப்படின்னா you will be coming up with the correct answer, that is Vm by pi into 1 plus cos alpha. That is the formula for this, right? இந்த இடத்துல என்ன வரும் அப்படின்னா if you replace cos pi by 4 by alpha, you will be getting cos alpha. So the generalized formula for single phase full conductor with a purely resistive load is V naught average equal to Vm by pi into 1 plus cos alpha. Am I right? Yes, this is the formula. Now Vmax, given it is sinusoidal voltage, RMS voltage, Vmax means you should multiply it by root 2. That's all. So root 2 into 130 divided by pi. 1 by root 2 will be 0.707. 1 plus 0.707 will be 1.707. Yes or no? It is very easy now. Now take root 2 into 120 into 1.707 divided by pi. If you put, I will be getting, yes, Geeta ma'am, you are correct. Good. 92.21. 21 volt exactly. That's all. That is the correct answer for the given question. Okay. I hope you all have understood this. It is very easy. There is no big things to explore. Fine, sir. Do one more thing. What you guys can do is, I just wanted to know the output power. I need only output power. Solve பண்றீங்களா? அவுட்புட் பவருக்கு என்ன பண்ணணும்னு நான் சொன்னேன். ரெசிஸ்டிவ் லோட் கொடுத்துருக்காங்க. அவுட்புட் பவர் எப்படி கால்குலேட் பண்றதுன்னு தெரியும். Do it by yourself. Drop your answer in the Telegram channel. Our group will drop it, not here. See, I am giving one more question. Given it is a 6 pulse thyristor converter, a 6 pulse thyristor converter is connected to is connected is connected is connected to the supply through transformer is connected to the supply through transformer of 6% reactance. Okay, sir. Next, if secondary side RMS voltage, if the secondary side RMS voltage is equal to 440 voltage, RMS voltage is 440, then calculate the voltage regulation of the transformer, whereas the output current is constant, continuous, of course, that will be equal to 150 ampere. Okay, this is given. So now we have to know transformer reactance கொடுத்திருக்காங்க, that is 6%. Transformer secondary side voltage, primary is connected with the supply. They told, see, 6 pulse வந்து நம்ம என்ன பண்றோம் அப்படின்னா connect to the supply through transformer லேயே connect பண்றாங்க. அப்படி connect பண்ணும்போது secondary sideல voltage வந்து 440 வந்திருக்கா. Under this situation, what can be the expected voltage regulation? Try this kind of new questions, because directly asking the question and இதுவரைக்கும் நம்ம சால்வ் பண்ணதெல்லாம் டைரக்டா என்ன கேட்டிருக்காங்க, V naught average is what, RMS value is what, power is what. We know these things, we know how to explore. Something should be new. நம்ம பார்த்தோம்ல symmetrical angle control, that's new for us, but it is beautiful to learn. Like that, voltage regulation transformer calculate பண்ணிருப்போம். Of course, in power system we did, in synchronous machines you did, but now in power electronics we are doing. Just happy and learn it. Okay, something going to happen miraculously in this circuit. How do I estimate the voltage regulation? For this question, don't spend too much of time. Try up to your maximum limit. If you are not getting the answer, no issues. In the next lecture I will be dropping the answer for this question. Okay, find the answer, drop it in the comment section.